In this video, I'm going to show you how you can find the average value of a function in 3D space. So cast your mind back to Calculus 2. I would give you a sine graph and ask you to find the average value of sine of x within 0 and pi. So I would ask you to imagine that this is water here, and you've got your fish tank, and when the water settles, it will settle somewhere around here, and this height is your average height. So here you can see that the height is high here, but then the height here is low. The height here is high, the height here is low. It turns out the average height is the one that's in the middle. So for you to do this, you would work out the area of one hump, which would be the integral sine of x dx from 0 to pi, and once you've got the area, you would divide it by this width. That will then give you the height. So for you to find the average value, you would divide it by the length, which turns out to be pi. So this whole thing here will then give you your average value. So now we can apply the same technique in 3D space. So for you to find the average value of this function, you would use double integration to work out the volume of this hump, and once you've got the whole volume, you divide it by the area of this circle. Because imagine you've got imagine this is water here, and you've got your glass. So this is your glass, this is your glass, and when the water settles, it will probably settle somewhere around here, and your average height is really the height of this thing here. Okay, so the idea here is to work out the volume of the whole thing, and then once you've got the volume, divided by the area of the circle. So we need to find the volume first. So the volume is given by the surface, and we need to establish our region. So our region is this circle here, and you can find the equation for this circle by putting 0 into the z, because here the xy plane, xy plane, put 0 into here, and then it will give you an equation of that circle, which is x squared plus y squared equals 9. So you can see that the radius is 3. Well, anyway, we could use this, but let's use polar coordinates, because you've got x squared plus y squared here, and you're integrating over a circle, so it kind of makes sense to use polar coordinates. So polar coordinates translate Cartesian into polar, and you're integrating from a radius of 0 to a radius of 3, radius of 0 to radius of 3, radius of 0 to radius of 3. So you're integrating from a radius of 0 to a radius of 3, and you're scanning from an angle of 0 all the way around here. So 0 to 2 pi, and your surface, well, in polar form, it would be this. Well, we've done this before. I'm expecting you to be able to jump from here to here. So now it's just a matter of integrating this. So when you integrate this, remember, you've got to get this times this times this. So when you integrate 9r, it will then give you this. When you integrate r to the power of 3, it will give you this, from 0 to 3, from 0 to 3. So now put 3 into here, put 3 into here, and then take away, put 0 into here, put 0 into here. That will then give you this, and then integrate it with respect to theta. That will then give you this thing, from 0 to 2 pi, from 0 to 2 pi. So now put this into here. That will then give you this thing here. So we know the volume is given by So we know the volume. We know that this volume here is given by this thing here. So so once you've got the volume, the average value of z is given by the volume divided by the region in which you're integrating over, which is pi r squared. The radius is 3, so that will then give you this thing here. So get the volume divided by the area, and then that will give you the height. So this is your average height. This is your average value of x of z. Okay.